Now, since we have learnt about addition of vectors, it's only logical that we shall learn about subtraction of vectors now. And interestingly, there are no new rules or laws for the subtraction of vectors. If you have understood the meaning of negative of a vector and you have learned the laws of addition of vectors by heart, and they are enough to be able to subtract two vector quantities as we shall see now. So let's quickly remember what we did in the case of addition. If there were two vectors, suppose P and Q, I could just add them by triangle law, where I just put them next to each other in the same order, that is the head of P coinciding with the tail of Q, and the resultant was given by the closing side of the triangle in the reverse order. Now this was of course the resultant, that was P plus Q. That was the triangle law, right? Triangle law. And what about the parallelogram law, what we did there? In that case, if P and Q are two vectors, we just arrange them so that they have a common tail. This is the P and Q vectors. They start from the same point and complete that parallelogram, and then draw the resultant as the diagonal to the common point, common tail, and that gives the resultant, which is in this case P plus Q. So even the construction can show you very roughly that we are getting the same answer here. By triangle law and by parallelogram law, the arcs appear quite the same, but of course I have drawn by hand, so you can't rely on this. This was the parallelogram law, right? This was the laws of addition for two vectors. And what we learnt about negative of a vector, if you remember, that if a vector, say, is represented by this arrow, then an arrow of equal length but opposite sense, anti-parallel, that will be the negative of the first one. That is, if I call this as a vector P, this one must be minus P, because they have the same lengths, parallel lines of support and opposite senses. This way and this the opposite, that's all. The angle between them has to be 180 degree for negative of each other. Now once we recollect these two things, the laws of addition of two vectors and negative of a vector, we have no problem to subtract two vectors knowing whatever we have already learned. Let's see how we can do that. First of all, let us consider two vectors. This is one vector and I shall call it the vector P. My job is to just subtract. We are trying here this operation, that is P vector minus Q vector by vector algebra. That is our work today. So see, this is the P vector, and suppose the other vector is Q that I have to subtract. This one is here somewhere written like this. So this is my Q vector. So when I say I have to find out P minus Q, these question marks will disappear because I'll learn at the end how to subtract vectors. So you see that I could write this quantity as the vector P and then plus, start a bracket right within that minus Q. So basically subtraction of Q minus P boils down to addition of the vector P and another vector that is the negative of the vector Q, that is minus Q. So P minus Q is equivalent to saying P plus minus Q, and since we have learned how to find negative of a vector here by just reversing direction, we know how to produce minus Q, how to construct minus Q, and then go for the addition rules which we have already discussed. So here is my P and here is my Q, and since I have to go for minus Q, what I do is that I just draw an equal length vector parallel to Q. They have got the same parallel lines of support, but they have opposite senses. This we call anti-parallel. Opposite sense, parallel lines of support and same magnitude, which make them, this next one it is definitely the vector minus q, the negative of the q vector. So as mathematical things show here, mathematical operation shows here that p minus q is same as p plus minus q. What you need to do is that we have to add the vector p with the vector minus q, and that is the vector subtraction in mind. So there are two laws for us, triangle law and parallelogram law. Let's see how we can apply these two laws graphically to subtract these two vectors. If we want to apply the triangle law, in such case we know that we have to join the two vectors end to end. So here is my p, and you can easily see I have shifted the vector keeping its length and directions intact. So this is quite possible because we consider it to be a free vector unless otherwise mentioned. This is my p vector. Minus q is of course this one, and I make sure that the head of the first one coincides with the tail of the next one. That is triangle law. Two vectors represented by two sides of a triangle taken in the same order. Let me name them to avoid any confusion. This was my p vector, and you can easily compare it. I have taken no liberty except to shift it, that's all. Minus q was this, so this one and this one, they have the same length and they are parallel. I just shifted minus q here. This is my minus q vector, right? So by triangle law I can say that the addition of p and minus q is the third closing side of the triangle in the reverse order, which means I have to join these 2 points, the tail of p and the head of minus q in the reverse order. That I am doing. I have joined the tail of p and the head of minus q, these two combining vectors, in the reverse order. You go from here, then here, same order, and go for this in the reverse order. That is the, what is that? That is the summation of p plus minus q, that is p minus q. So yes, this is my p minus q vector, right? This is the p minus q. We don't have any word for that. For example, if I have p plus q, we use the word resultant, but p minus q should be called vector difference, that's all. There is no particular word for that p minus q. This was of course triangle law of vector subtraction. Now I shall do the same result we'll arrive at by the parallelogram law, which we are aware of. Okay, so once again let's start. This was my p vector. As we can see, everywhere I have kept the same p's, direction and length same. This was my p, and in parallelogram law you are aware that the two combining sides, combining vectors should be joined at the tail. They must have the common tail. So if it was my p, I must shift my minus q in such a way that they have a common tail. That we have done here. Yes, this is the case. The figure becomes slightly difficult to draw, but I'm sure I'll complete it. So let's see what I have drawn. I have drawn the vector p and drawn the vector minus q, keeping their lengths and directions intact, but making sure that they have a common tail. In case of triangle law, the head of the first one and tail of second one coincided. In parallelogram law, both the tails coincide at a single point, and we have to construct the parallelogram law carefully. Well, let me name it first. This was my vector p, and this is the point where they have met, and this was my vector minus q. I take a little time for construction here. Well, I can share the figure with you now. You see that this was p and this was minus q, and since they had a common tail, they formed the adjacent sides of a parallelogram, and I did the difficult task of constructing this parallelogram. That was slightly difficult because the angle is very huge. And once I have drawn that, we can draw the resultant of p and minus q the different colored ink, that is my choice. I start from this common tail of P and minus Q, and I get my arrow to be this. Just see it carefully. This was my construction of the diagonal of the parallelogram, of which P and minus Q form adjacent sides with a common tail. The diagonal was this red arrow extending from the common tail of P and minus Q to the opposite point here on the parallelogram. So this once again stands for my P minus Q. This red vector, of course, is my P vector minus Q vector. So I have shown, this is, of course, let me call it, this is parallelogram law application. Okay, this is parallelogram law.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.